I just want you to relax. I just want you to take the time to listen, take the time to reply and talk along with me. Pause this whenever you need to think and repeat any parts you need to. I don't want you to take any notes. I don't want you to be actively straining your mind to try and remember. If you feel more comfortable just sitting down and maybe doing something with your hands to distract yourself so you can be fully relaxed, feel free. Because we need to be ready to try and let this information into our brain. Because today we're going to be talking about vectors and scalars. So the force to keep somebody staying in the air is going to be dependent on their weight. But first we need to talk about a force. A force at the simplest level is a push, a pull, or a twist. So what are the three things that a force is on the most basic level? It could be a push, it could be a pull, or it could be a twist. Now, when a force acts on an object, it can cause it to accelerate. So when a force acts on an object, what can it cause it to do? It can cause it to accelerate. At the simplest level, a force is a push, a pull, or a twist. And when a force is acting on an object, it can cause it to accelerate. Now, whenever we're talking about a quantity, something that is quantifiable, we like to talk about its units and whether it is a vector or whether it is a scalar. So our force, its units are newtons, and it is a vector. So when we're talking about a quantity like force, what two things do we like to say about it? We like to say that it is measured in newtons and it is a vector. So we should know a few things about forces now. On the simplest level, it is three things. A push, a pull, or a twist. When a force acts on something, it can cause it to accelerate. Perfect. And whenever we're talking about a quantity, we like to talk about two things. We like to say its units and what type of quantity it is. And so for force, that would be it's measured in newtons and it is a vector. So we can say all those things together now. On the simplest level, a force is a push, a pull, or a twist. It can cause things to accelerate. Its units are newtons, and it is a vector quantity. Now we can start to use those same facts to talk about another quantity, to talk about the weight of something. So the weight is the force pulling an object downwards. So we can just think about ourselves being pulled downwards to the floor. Our weight is the force pulling an object downwards. So what are the three things a force can do? It can push, it can pull, or it can twist. And what is weight? Well, weight is the force pulling an object downwards. A weight is dependent on two things. It's dependent on the mass of our object, how massive it is. How massive that object is, how much mass it has, is going to affect its weight. And also the gravitational field strength. How strong that gravitational field is of where our mass is. Okay? So our weight is dependent on the mass of an object and the gravitational field strength. So what is our weight dependent on? The mass of our object and the gravitational field strength. So remind me again, what can forces cause? Forces can cause an object to accelerate. And there's two things we always like to say about a quantity. We like to say its units, and we like to say what type of quantity it is. So what are the units and what type of quantity is force? Force is measured in newtons, and it is a vector quantity. What about weight? Weight is measured in newtons, and weight is a vector quantity because weight is a force. What is weight? Weight is the force pulling an object downwards. And what is it dependent on? It is dependent on the mass of an object and the gravitational field strength. Perfect. So, now what we want to talk about together is we want to talk about what we meant by vector. A vector is a quantity, something we can quantify. A vector is a quantity that has both a size and a direction. And an example would be a force and weight. A vector is a quantity that has both a size and a direction. What would be an example of a vector? A force or a weight, because it has a size and direction. What is the direction that weight has? Weight has the direction of the force pulling the object downward. What are the three directions a force could have? It could be a push, a pull, or a twist. So a vector is a quantity that has both a size and a direction. There's another word we could use for size. We could use the word magnitude. Magnitude is another word for size. Magnitude. The size of something, such as the size of a force or the size of a weight. What do we measure the magnitude of force in? We measure the magnitude of force in newtons. What do we measure the magnitude of weight in? We measure the magnitude of weight in newtons. What type of quantity is force? It's a vector quantity. And what is a vector quantity? It's a quantity that has both size and direction. What's another example of a vector quantity? Weight, because weight is the pulling of an object downwards, measured in newtons, a vector quantity. What are the two things that weight depends on? It depends on the mass of an object and the gravitational field strength. Let's talk about mass a little bit more. Mass is a measure of how massive an object is. Mass is the measure of how much material there is in an object. Mass is the measure of how much material there is in an object. What is mass the measure of? It's the measure of how much material there is in an object. What two things do we like to say about a quantity? We like to say what units it's measured in and what type of quantity it is. Mass is a scalar quantity. Mass is measured in kilograms and is a scalar quantity. What is mass a measure of? It's the measure of the amount of material that is in an object. What two things can we say about mass? We can say the units are kilograms and mass is a scalar quantity. What is a vector quantity? A vector quantity has both size and direction. What's another word for size? Magnitude. Magnitude is the size of something, like the size of a force. So let's talk about a scalar quantity. A scalar quantity has a magnitude, but not a direction. What's the example of a scalar quantity we've already talked about? Mass is a scalar quantity because it doesn't have a direction. Why is weight a vector quantity? Weight is a vector quantity because it is the force pulling an object downwards. Why is a force a vector quantity? A force is a vector quantity because it has the direction of a push, a pull, or a twist. Why is mass not a vector quantity? Mass does not have a direction. Mass is the amount of material there is in an object. Its units are in kilograms and it is a scalar quantity. Quick questions to finish us off. On the simplest level, what is a force? A force is a push, a pull, or a twist. What can forces cause objects to do? Forces can cause an object to accelerate. What else can we say about the quantity of force? Its units are newtons and it is a vector quantity. What is weight? Weight is the force pulling an object downwards. What are the two things weight depends on? It depends on the mass of an object and the gravitational field strength. What can we say about the quantity of weight? The units are newtons and weight is a vector quantity. What does the word magnitude mean? Magnitude is the size of something, such as the size of a force. What do we mean by a vector quantity? A vector quantity has both a size and a direction, like a force or a weight. What do we mean by mass? Mass is the measure of the amount of material there is in an object. What two things can we say about the quantity of mass? Mass's units are kilograms and mass is a scalar quantity. What do we mean by a scalar quantity? A scalar quantity has a magnitude but no direction. An example would be mass. Hopefully you find this process useful. Hopefully you've been sat there relaxed, just repeating this information back at me, answering my questions and not struggling to make notes. If you'd like to make notes, please do that in your own time afterwards. But I'd like you to just talk through these ideas so we can try and commit those to are memories. I don't want us to memorize, I want us to remember them.